The common reactions of benzene are electrophilic substitution reactions. Alright, so what happens in electrophilic substitution reactions, I will be explaining out here. You have benzene ring, and what happens is electrophile attacks on benzene ring, and this bond is broken up, H plus and E plus attaches in place of H plus. So you get a product like this. So what is actually happening is electrophile is replacing electrophile. So the reaction is known as electrophilic substitution reaction because one electrophile is coming in, another nucleophile is going out. Now we have electrophilic substitution of 5 types. What are the 5 types? The 5 types of electrophilic substitutions reactions are halogenation, nitration, sulfonation, Friedel-Crafts alkylation and Friedel-Crafts acylation. So overall 5 electrophilic substitution reactions are there. What is the basic mechanism? Come on, let's study that. So step 1 is generation of electrophile. Generation of electrophile is the first step. So in this step, what happens is electrophile is generated. For example, I am doing halogenation. So the catalyst is A anhydrous AlCl3. So what will happen is AlCl3 is electron deficient. So what will happen? It will break Cl2 into Cl plus and Cl minus. This Cl minus will attach to AlCl3 and AlCl4 minus will be formed. So Cl plus electrophile is generated like this. Similarly, in nitration, you have a mixture of sulfuric acid and nitric acid, and the electrophile is NO2 plus, which is a nitronium ion. And how it is formed, I am explaining you that. Nitric acid, this is nitric acid. So what happens is, in this, sulfuric acid acts like a acid because it is a stronger acid, and nitric acid acts like a base because it is comparatively a weaker acid as compared to sulfuric. Right? Both are strong, but sulfuric acid is a stronger acid than nitric. So this will give H plus and nitric acid gives OH minus. This nitrogen gets a plus here, minus, and here plus. So water is removed and NO2 plus is generated. So what all we get here is NO2 plus, which is electrophile for nitration, then HSO4 minus, and along with that we get water. So this is electrophile generation in nitration. Similarly, we have sulfonation where the electrophile is SO3. So we take oleum, it is a mixture of sulfuric acid and SO3. So SO3 is present in oleum, so it is used as such. In Friedel-Crafts alkylation, we have RCl and we take AlCl3. Same happens as in halogenation. The bond breaks up, you get Cl minus and R plus. This Cl minus attaches to AlCl3. We get electrophile required R plus along with AlCl4 minus. Next, in acetylation of Friedel-Crafts acetylation, we take AlCl3 along with RCOCl. This breaks like Cl minus and CO plus, and this Cl minus goes with AlCl3. You get the electrophile required RCO plus and AlCl4 minus is formed along with that. So I have explained to you how the electrophile is generated in electrophilic substitution reaction. This was the step 1. Now in the step 2, electrophile attaches to the rhenium ion. Rhenium ion is formed. See, you have benzene ring. What will happen now is you have electrophile, let's say E plus. This bond breaks towards this and you will get a negative here. This attaches to this electrophile and rhenium ion is formed. Rhenium ion is something like this. I will make it again. This is rhenium ion. Here you have a plus. This is rhenium ion. This is resonance stabilized. Alright. So step 2 is formation of rhenium ion. Formation of rhenium ion. This is also known as sigma complex. So this is also known as sigma complex. So second step, formation of rhenium ion, and the step 3 or the final step is deprotonation. Because benzene ring shows aromaticity, this double single structure is highly stable, which is disturbed over here. So benzene ring will gain back its pi bond, and that happens by deprotonation. What will happen is this hydrogen carbon bond will break, and here H plus goes, and there will be minus minus and plus will form a bond. So you get the product which was required like this. This is the final mechanism of electrophilic substitution reactions. What is happening? Commonly in all the compounds which have benzene rings. So benzene ring containing compounds can have electrophilic substitution reactions depending on the reagent present, either halogenation or nitration or sulfonation or Friedel-Crafts alkylation or Friedel-Crafts acylation. Any of these 5 reactions can be found if benzene ring is present in the given compound. Other type of reactions in the pi bond containing compounds are addition reactions. So if we have alkenes or alkynes, the common reactions are electrophilic addition reactions. How the name comes? The name actually comes from the attack of first species. If first species is electrophile, which is attacking, then the reaction will be known as electrophilic addition. So common reactions of alkene and alkyne are electrophilic addition reactions, whereas benzene shows electrophilic substitution reactions. Benzene does not show electrophilic addition. So thank you.